Hello and welcome to part 3 of this video series on Python programming. Let's start with another important topic which is about comprehensions. These are simple constructs that are sometimes referred to as syntactic sugar and these are shortcuts designed for frequently used functionality to improve the code readability and making it more concise. So let's say we have this cell 135. So we have um, a list numbers that we use in the previous part of the video series. We can also print it and have a look at it. So numbers, so we have 5 elements in this list container, and what we want to do is to square these numbers. So one way of doing that is to start with an empty list, so that is squared numbers here, and then we can use a for loop. We have seen in the last video how to use a for loop. So if we use for num in numbers, and then we square each number and append it to our list square numbers. And if we run this, that's what we get: 4, 9, 49, 36, and 1, which are the square values of the original numbers. Yeah, so these are our original numbers here. Another way of doing that is to use list comprehension, and list comprehensions are, as I said, like very simple constructs. So instead of writing 3 or 4 lines of code, we can get the same results from a single line of code. And this is how we do it. We write squared numbers again, and we start a list. And within that list, we do num multiplied by num for num in numbers. And that also gives us the same results. And similarly, we can also run comprehensions on dictionaries. For example, we have keys corresponding to these numbers. So we have A, B, C, D, and E. And then we saw in the previous parts that how to create a dictionary from keys and numbers. We can use the dict construct and then zip on keys and numbers, and that gives us the dictionary where each key corresponds to a value in our numbers list. To run the dictionary comprehension on this, we can use a similar construct. So D2, instead of the square brackets in dictionary, we use curly brackets. So K is a specific key, and V is a value, and we want to square the value, so we are multiplying V with itself. For K and V in D1 dot items. So D1 dot items gives us the pair of key values, and that we are using in this dictionary comprehension, and we end up getting D2, which is another dictionary, but with the value squared. uh, so if we run this cell, yeah, that's what we get. 2 has become 4, and 9, 49, 36, and 1. So these are very useful. It definitely improves code readability and reduces the lines of code in a program. Um, let's move on to our next topic, which is also very important topic, and that is about functions. So what is a function? A function is a group of related statements that can be called together to perform a specific task. So why do we need these functions? We need them because when the programs get bigger and more complicated, they also become more difficult to read and debug. We can use functions to minimize the redundant logic and also manage code complexity and improve the code readability. So these are also very useful in programming. So let's say we want to get the square of the numbers. Um, then we could write a function like this. So it starts with the def keyword, so the def, and then we write the function name. In this case, we use squared, and then it takes a list of arguments or different arguments, and then it can also take some keyword arguments as well. So here what we are doing, we are reading from the arguments, and for each of the argument we are squaring um, the argument and returning it back as a list. Now we can use this function squared. We have to unpack the number so that each element becomes an argument, and then we can compute the square and return it as a list, as our original numbers container is a list. So let's run this one, this cell here. We get this list of the squared numbers as before. Let's look at another example. In this example, now we have two lists instead of one. So we have assigned numbers two, which are based on the square values. And what we want to do, we want to add this list um, to the list that we originally had. So for that, we can also write a function, the same construct, def keyword, and then the function name, and then arguments and keyword arguments. Now in this function, our arguments are basically two lists instead of unpacking of the list. So we can read from the list. So argument 0 is list 1 and argument 1 is list 2. So we zip it and then take each element from that list, and then we add those elements and return the list of the sums. And if we print our numbers first and then print numbers 2 and then sum list numbers and numbers 2. So as I said, like, we are not unpacking these numbers, we are inputting them as list. And if we run this, we can see we have 2 plus 4, which is 6. So we get the correct sum of these two lists element by element. Okay, so this is how we can write functions in Python. There is another important type of function that we can use, and those are called anonymous functions or lambda functions or inline functions. And for that, we can save the functions like this. So polynomial equals to lambda, and it takes the input argument as x. And what this function is doing here is taking this input x and outputting a polynomial, so which is x squared plus 2x plus 1. So if we are to get the polynomial of 5, we can see that 5 squared is 25 plus 10, 35 plus 1 is 36. So that's the answer we should get. And if we are using polynomial of, let's say, 1, we should get 1 plus 2 plus 1, which is 4, and that's what we get here. This is all I wanted to talk about functions. These are also very easy to write and very useful and powerful to improve code readability and to minimize the redundancy in the code as well. Okay, so let's now move on to another important topic, which is decorators. So what are decorators? Decorators are design patterns that augment the behavior of an existing object. So by doing so, it kind of decorates the original behavior of the function. So they allow wrapping another function to extend its behavior, but without permanently modifying the original function. So let's see how this works. Let's create some more cells here. So let's say we have a function compute polynomial, and it takes an input argument x and then returns the polynomial of that function. So we just copy this from here and place it here. And if we try to compute the polynomial of 1, we should get 4, and that's what we get. And with 5, we should be able to see the answer equal to 36, and that's what we get here. Okay, so one way of looking into this function is that now we can only use this function for a single element. So what if we try to input our numbers list instead of a single x, compute a polynomial, and Then we input numbers as the argument, and if we run this, we see this error that can't multiply sequence by non-integer of type list. So one way of doing that is to use the map functionality within Python. So we could use that to square the numbers again, or compute the polynomials. So let's say we want to do the polynomial calculation. So we say list map, and then we provide the function, so compute polynomial, and then we provide the arguments, which is our numbers list here. And if we run this, that's what we get. So one way of doing that is this. Another way we just saw in the previous exercise of comprehensions. We can write polynomial values, and that is equal to compute polynomial of let's say x for x in numbers. Okay, and if we print this, we should also get the same answer. So we can also write a decorator here in this case, and for that we need to define a function that takes another function as the input parameter, and then return a new function. So let's write our list mapper. So we write a function, call it list mapper, and give it the argument function, our function, as the argument. And let's write the inner function. So def inner, and it takes arguments. Okay, so now we just need to check the length of arguments. So length of arguments, if it is greater than 1, it means our input has more than one uh, values as arguments, and then we could simply return um, list map function and arguments, and that will cover the list. Elif length of arguments is equal to 1. When the length of arguments is equal to 1, we can simply return a function of args, and else we can raise uh, um, a type error, and that is missing arguments. And finally, we return the inner function. Okay, so let's see how we can modify our compute polynomial function and add a decorator to it so that we could directly input our list. So uh, if we give numbers list to our compute polynomial, it says can't multiply sequence by non-int of type tuple. Okay, so let's give it another try. Okay, let's see if this works. If length of args zero is greater than 1, then we could return for x in args 0. Otherwise, we return a function of args. And this works for the numbers list now. So the thing is that if we don't give the unpacked list as arguments, it will look for the length of the argument specified in arg0, and if it is greater than 1, then it will treat it as a list. So for each element in the list, we are applying the compute polynomial function. And in another case, if we have unpacked our numbers list, the function will also work. And now if we specify a number, let's say 2, the function object has no length. Okay, so now we got another error, has no length. So let's see if we could change this list mapper again. So let's say if we have, instead of writing it like this, so if we could write, yeah, so let's first check if is args is instance args of int, or is instance args is a float, we can return function dot arguments, and if it's not, we can return it as a list. So let's see how does this work now. Again, object type of int has no length. Okay, so we need to update the int object is not iterable. So we simply need to give function arg. Args of 0 and can't multiply sequence by non-integer, so we'll have to unpack it again. Okay, now we got it right. Okay, so let's double check again and that we haven't broken our functionality. So numbers, and it's working, and if we unpack, our numbers list is still working, and if we give an integer, it also works for this, and we can also try it on float, should also work on floats as well. So now everything is working. Yeah, sometimes it gets a little bit tricky, but a little bit of debugging and looking at the code will help you fix the code uh, quickly. All right, so this was all about decorator. We can simply write these functions without modifying the original function. So you can see that we haven't changed the function at all, but now we could cover different types of data formats using the simple function written here by just adding this decorator on top of it. Um, Okay, so now let's look at the final topic, which is classes. Python is an object-oriented programming language. Um, so almost everything in Python is an object. And what is an object? It's an instance of a class. And a class is kind of a template that allows including behavior or methods and states, for example, variables, data, or attributes to a particular object. There are four principles of object-oriented programming. I won't go into more detail here, but in a nutshell, these are encapsulation, abstraction, inheritance, and polymorphism. And encapsulation is the ability to restrict access to variables and methods. By doing so, we prevent these from being modified by accident. And abstraction, it means hiding the real complex implementations and only showing the essential features of the object so that a user only knows how to use it. In Python, we use a double underscore at the start of the method or variable's name to indicate it is private, that is for encapsulation, and for abstraction, Python offers the abstract base class module to create abstract classes and methods. Then inheritance allows creating new classes using classes that have already been defined. In this case, the class from which another class inherits attributes and methods is called the base class, whereas the inheriting class is called the derived class. And then lastly, polymorphism is the ability to process objects differently depending on their data type or class. Yeah, so let's start with our class. Or let's say we have a vehicle class, so we can start with the class keyword, and then we can write our class name, vehicle, and then classes names are typically in upper camel case, such as vehicle or my vehicle, like this. So I'll just keep it as vehicle, and then we have to initialize the classes. So we can write the def method, def init self, and it can take arguments, and it can also take keyword arguments. And self here is pointing towards the class itself. So let's say we have three arguments. So self dot color, we want to know the color of the class. We can assign the color. We can also see the doors, how many doors this car has, and that will be the argument at index 1, and then self dot tires is equal to arguments 2. And we can also write double underscore str method to print or describe the instance when the class is printed, and we can write that return an f string, and this self doors door vehicle has self color and self dot tires, and we can return this. So this is a simple way of writing classes. And we can also write some methods or behavior to our vehicle class. So for that, let's say we have a braking function. So if we say normal brake and apply self, so what should it return? It should return so slowing down. And if you apply hard brake, so the tire would return this sound of screech. And if you turn right, the car should turn right. And so on. So we can also write methods like this, and the attributes of the car are the color, doors, and tires here. So let's run this cell and create a vehicle instance. So we say car is equal to our class vehicle, and as I said, like we have three input arguments. So we say the color is blue, and the doors it's a 4-door vehicle, and the tires, it also has 4 tires, and we can check. So it's a main dot vehicle class, and if we want to print this car, so we can see the string from the underscore str method. This 4-door vehicle has blue color and 4 tires. And we can also see some functionality. So we apply normal brake, car dot normal brake, and it's slowing down. You can also look at color of the car, doors of the car, and tires of the car, and these are the attributes, and blue 4 4. Okay, so let's see now we have different types of car, and we want to keep the same functionality as in our vehicle class, but now we are creating another class called gasoline car, or and it inherits from the base class vehicle. And what we need to do is init and self args and keyword arguments, and we need to just pass our super class. So super gasoline car and self and dot init, and we need to pass the arguments and keyword arguments that will initialize the parent or base class. And then we can also add another private variable which is engine, and we can say it's a V6 engine. Okay, so now let's see, we add more functionality to our class. So let's say definition log windows and self, and we can return windows are locked, and we can also say make noise, and we should return noise. And since engine is an encapsulated or private variable, we cannot normally see it, but if we want to see it, we can write another function or method which is get engine, and we can return self dot engine. Okay, so yeah, let's run this now. So we have our gasoline car. So let's say we have our G car, which is gasoline car, and again we provide blue 4-door 4 tires, and that's our car. Now if we want to see G car dot underscore underscore engine, we won't be able to see this because this is a private variable, but if we want to check this, so we can say get engine, and now we are able to see V6, that this car has an engine of V6. Okay, so that was inheritance and encapsulation, and similarly, we can include the abstract classes from Python functionality, and also use polymorphism principle in when writing our classes. So this was all about classes. Lastly, I have bonus contents which is on modules. Modules are very helpful and often used. It's a file containing Python definitions and statements. So Python has built-in modules that we could use, import and use and into our programs. And we don't need to really rewrite the entire code by ourselves. There are tons of libraries and packages for different modules that we can simply import into our program and use the functionality and make our life easier when programming. So let's see how does that work. So for example, I'll give an example of importing a module. So we have let's say a math module, so we can import it by saying import math, and that should import all the functionality in the math. And what kind of functionality do we have in math module? So we can see using dir command, and all of these functions are available to us. So what if we don't want to import everything from math? We simply are interested in, let's say, assign function and pi. So let's say we can import those like this. So from math, import assign and pi. So let's say if we want to um, check the sign of a sign of 1, so a sign of 1, that should return us the angle in radians. In order to convert it to degrees, we need to multiply it by 180 and divide by pi. um, so that is the answer. So sine of 90 is equal to 1. We could also, because we have previously imported import math, so we could, if we write math dot a sine 1, this should also work. And if we want to, let's say, import everything from math library, we can also import it like from math import everything. So now we have everything here, and if we want to see a of cosine, let's say 1, and do the same operation, multiply it by 180 and divide by pi, we get 0 degrees. So cosine of 0 degrees is equal to 1. So this was all about our learning Python programming course. I hope you liked it. There is a lot of functionality, so keep practicing and write programs. And the more you will write, the more you will learn about more functionality. And whenever you write your programs, so just keep in mind the tips and tricks of different functionality that is already available to you, and make use of it. So yeah, again, thanks for watching, and I hope you like this video, and please subscribe to my channel. Thank you.